Hello, and welcome to Philip Brown's Computer Networking Lab. You're watching the instructional video called Gateway Load Balancing Protocol. In the previous video, we saw how Hot Standby Router Protocol and Virtual Router Redundancy Protocol features could be used to produce a redundant network. We can accomplish load sharing by configuring multiple virtual routers. Unfortunately, more manual configuration is needed so that the client machines are divided amongst at least one or two different default gateways. This makes load sharing somewhat labor intensive, giving it a fixed or static behavior. The Gateway Load Balancing Protocol is a Cisco proprietary protocol designed to overcome the limitations of other router redundancy protocols. As a client sends an ARP request looking for the virtual router MAC address, the Gateway Load Balancing Protocol sends back an ARP reply with the virtual MAC address of the selected router in the group. The result is that all clients use the same gateway IP address, but have different MAC addresses for it. The advantage is that none of the clients has to point towards different gateway addresses. They can all have the same default gateway set on the one virtual router IP address. The load balancing is provided completely through the use of virtual router MAC addresses from ARP replies returned to the client. In the disabled state, the virtual IP address is not configured, but the Gateway Load Balancing Protocol options may be configured. In the initial state, the virtual IP address is configured, but the physical interface has no IP address or just came up. In the listen state, the virtual gateway receives hello packets and learns the status of the Gateway Load Balancing Protocol network. In the speak state, the virtual gateway sends and receives hello packets and may be one of several routers to become the next standby router. In the standby state, this virtual gateway is the next in line to become the active router. There is only one at a given time. In the active state, this virtual gateway responds to ARP replies for the virtual IP address. There is only one at any given time. The round robin mode means that each new ARP reply for the virtual router address receives the next available virtual MAC address in reply. Traffic load is distributed evenly across all routers participating as active virtual forwarders in the group, assuming that each of the clients sends and receives the same amount of traffic. This is the default method used by Gateway Load Balancing Protocol. The weighted mode means that the Gateway Load Balancing Protocol group interface weighing value determines the proportion of traffic that should be sent to the active virtual forwarder. A higher weight results in more frequent ARP replies containing the virtual MAC address of that router. If interface tracking is not configured, the maximum weighted value configured is used to set the relative proportion among active virtual forwarders. The host-dependent mode means that each client that generates an ARP request for the virtual router address always receives the same virtual MAC address in reply. This method is used if the client has a need for consistent gateway MAC addresses. The MAC address of the host is used to determine which gateway MAC address the host is directed toward. The GLBP IP command assigns an IP address to the virtual router. The GLBP priority command assigns a priority value to the virtual router. The GLBP preempt command allows a physical router to play the role of a virtual router if it loses the role. The GLBP wait command assigns a weighted value to the virtual router. The GLBP authentication command allows the GLBP router to talk to other routers using encryption. The GLBP waiting track command allows the priority value to be decremented if an interface goes down. The track interface command monitors an interface to see if it goes down. The show GLBP command shows the configured values of the GLBP attributes. Here we are looking at the terminal window of router A. Let's take a look at the running configuration. The gateway load balancing protocol is configured on Fast Ethernet 0/1. We can see that it has an IP address, a priority of 120. It's set for preempt. It has a weight of 120. It's using authentication. And it's set to decrement by 55 if the interface goes down. Here we could see these two commands used to configure the tracking. Now let's take a look at the terminal window of router B. It's also set on interface Fast Ethernet 0/1. It has a similar configuration to router A, but an important note is that its priority is 110, which is less than router's A. This means that router A will be the active virtual forwarder. It also has a decrement value of 30. Now let's take a look at the status of the gateway load balancing protocol. We see that it's set up as group 1. It is also active. Now let's look again at the terminal window of router B. It is also a member of group 1, but it is currently in the standby state. Now let's take a look at the terminal window of computer 1. When we ping 10.1.1.1, we see that it's successful. And if we run a trace route, we can see that it is using router A to connect to the internet. And when we go over to router 2, we see that one is also able to connect to the internet. And the trace route shows that it is using router B. Let's go back to computer 1 and run a show ARP command. We can see that the default gateway of 10.0.0.1 has the MAC address of router A. But when we do the same thing on computer 2, it shows that the default gateway of 10.0.0.1 has the MAC address of router B. An important tool for network administrators is the ability for network environments to load balance. I hope this video was informative, and I thank you for viewing.